right now, what I want you to do is I want you to practice doing the double replacement reactions. And so what we're going to do is we're going to predict what's going to happen in each of the reactions in the demo. And then you're going to bring them to me, and I'm going to check them off. If they're wrong, I'm just going to give it back to you, and you have to fix it. And then bring it up again. So you have basically you have. I'm just going to give one check, because what I've done in the past is I've just said, okay, it's wrong, go fix it. And they bring it up again, it's still wrong. Bring it up again, it's still wrong. And so to avoid that and having a long backup, and people just coming over and over until they get it right, I'm going to give you one check to fix it. You know, if it's wrong, you bring it up. And then if it's good, then move on. You know, or maybe should I give you 2 checks? We'll see, 1 or 2 checks. But if you still get it wrong and you continue to get it wrong, then you'll have to figure it out yourself on your own, basically. Because the way this one's going to be graded is it's going to be all right or all wrong. So even if you make a minor mistake, like you forgot to put liquid here, you know, I'm not going to tell you you forgot to put liquid there. You're going to have to find it. You're going to lose all the points for that. And so it's going to be all right or all wrong, no partial credit for these. Okay, but you can work together and figure out what you might be missing based on what other people, you know, somebody else probably figured it out. Are you talking about yeah, experiment 17. So experiment 17 you're going to first do on paper, and then we're going to do it as demo. But the paper part, you're going to come and get it checked off, and I'm going to check these off as you go along. And so do a few of them, bring it up, you know, and then I'll check it off and see. Okay?
On a separate sheet?
No, in your lab notebook. Leave some room for observations. You're going to take observations for these reactions as well. And so you don't have to do it side by side. You know, underneath we're going to write, what did this look like? What did that look like? What happened? That's it. And so again, does everybody know what they're doing? Okay, give me the first reaction. Somebody tell me the first reaction, I'll do it for you. How about that?
After the ones you already did?
No, I'll skip the electrolytes and go to the reactions. The reactions are you mixing chemical A with chemical B. So just find the first reaction. Did you guys, how many of you took Chem 4 here? Okay. This would be similar to that one lab. This experiment 17 is almost the exact same as the ions lab in Chem 4. And so it's very similar. So the first reaction is what? Yeah, wherever it is. What are we mixing together? Lead acetate? Lead 2 acetate or lead 4 acetate?
Lead 2.
All right, so the first thing is we have to write out the formula. So lead 2 acetate, we write out the formula for that. Is it soluble? Well, acetates are all soluble, so we say it's AQ. AQ you don't have to write. Plus, or don't look at the chart. Go to the procedure. Is there a procedure written for this? No.
The procedure is like a sentence long. It says the instructor will mix appropriate amounts, indicators, and observations.
Okay, so we're mixing lead 2 acetate with what? Just pick the first one.
Carbonate?
Sodium carbonate. So lead 2 acetate plus sodium carbonate. And then there's a box where you write your observations, but I don't want you to write anything in that box, because what I want you to do is I want you to write it in your notebook, not on the report sheet. And we aren't going to make a little box, or we aren't going to make a table. We're just going to do the reaction and then see. This, flip the page over onto the report sheet. Then there should be lines where you write this, right? But don't write it there. I want you to write it in your notebook. Okay. And so what we're going to do is we're going to write the complete equation, and then the ionic equation, and then the non-ionic equation. Okay, all in your lab notebook. Okay, again, don't write it on the report sheet. All right, this is what we call a double replacement reaction. AB plus CD. Predict the products for me. Lead 2 carbonate, then sodium acetate. Okay, the next thing is we look for driving force. Before we waste any time balancing this, let's make sure it happens, because if there's no reaction, there's no need to balance it, right? And so what is the driving force for this? Yes, what's a solid? Yeah, this precipitation. And so we say precipitation is the driving force for this. Okay, now let's balance it, because we'll just need 2 sodium acetates. Okay, the next step is to determine the ionic equation. Determining the ionic equation, what do? You separate what? No, you don't separate the ions. For everything, you can separate the ions for what? Separate into, for the aqueous species? No. You dissociate what? There's just 3 things. You should commit it to memory. You dissociate 3 things. What are the 3 things? Or one thing, if you want to classify it. But most people, when I say one thing, they get mixed up and they don't know. So, what are the 3 things you dissociate? Well, that's one thing, strong electrolytes. And people come up to me and ask me, what is a strong electrolyte? And so then I stopped calling it strong electrolyte. I started saying what? Strong acids, strong bases, and soluble salts. And so the first one, strong acid, soluble salt. So what does it break up into? Two acetates. A lot of people don't write the charge here. Or they write one charge and leave off the other. Try not to make that mistake. And then, a lot of people don't write 2 here. They just write 1 acetate. Try not to make that mistake either. I end up wasting a lot of time with this. The people do this, or people do this, or people do this. You know, is there charge on this compound? No, there shouldn't be any net charge there. People do this all the time. Or people do this. AQ, AQ. If you're going to write AQ, then you got to write it for, yeah, because if you leave this blank, then I'm going to mark it wrong. Those are the most common mistakes. Mm-hmm. Yeah, all the AQ's blank, but not the solids, liquids, and gases. Okay. Sodium carbonate, what is that? Yeah, it's a soluble salt, 2Na+. Got 3,2-. Lead 2 carbonate. Yeah, insoluble salt. Sodium acetate. plus. Well, let me just finish this. 2 acetates. And then we get rid of the spectators. I don't want you to cross this out in the ionic equation. I know everybody crosses it out, but I don't want you to, because the ionic equation is important in itself. It's not a transition in getting from the complete to the net. So we should leave it intact whole. And so don't cross anything out. Just, if you want, you could underline it. And so sodiums and acetates don't participate in anything. So it's lead 2 plus carbonate yields lead 2 carbonate solid. Okay, then we're done. Then we move on to the next one. So the first one I'll do for you, and then you just continue doing the rest. Try to work quickly on these so you can complete it. Otherwise, you'll have to complete it on your own and then just turn it in for all or nothing. Okay? All right, so go ahead and do that. I'll be back.